Chapter 4 is about making decisions in computer programs. Today we'll study something called Boolean expressions, and when a computer makes a decision, it evaluates a Boolean expression that's either evaluated to false or true. The computer uses zeros and ones to represent false and true, and everything inside the computer is represented in terms of zeros and ones. So to remember the selection structures that we looked at in Chapter 3, at the beginning of Chapter 4 in figures 4.1 and 4.2, they'll give you a picture of that, reminding you that if you've got selections, you need to draw on your flow charts coming out of both sides and then meeting down at the bottom. There are so many examples on these pages 126 to 134. It's very important for you. You can understand all of these, but you have to go through them and look at them in detail. This reference on 4.2 gives us something that we're using for comparisons, and this will help us in our Boolean expressions. But these operators are things that you've used in your everyday life, but you're seeing them here as a different kind of an operator than the arithmetic operator. So we'll compare things and see if they're equal to each other. If one on the one operand is greater than another one, so the position is very important. When we ask, is x greater than 5, the x has to be on the left in our computer program. We can also check for less than, and sometimes we need to check and make sure that we've got less than or equal or greater than or equal. And we also want to know sometimes if something is not equal. Both of our operands, that means the two things that we're comparing, have to be of the same type. So we'll compare floats with floats, ints with ints, strings with strings. That's not true in all languages, however. The values compared can be variables or they can be constants. So I can compare x and total and num1. I can also compare with 10 and 5 and 4. Usually, well, on the left-hand side of the equation, we have to have a variable, and on the right-hand side of the relation, we'll need some kind of a constant or a variable, usually. The result of the comparison is always going to be true or false. And page 134 points out a common mistake that many of us make, checking boundary conditions and, for example, asking is x less than 5, when really what we want to do is ask is x less than or equal to 5, because the being equals is a very important condition. Truth tables. We're going to just look at this as being two switches to a light bulb. And our first Boolean operation is and we'll say that the light bulb turns on. That will be our condition if x is true and y is true. So if both of them are false, the answer will be false. If one of them is true and the other is false, then the answer is still false. Until we get down to the bottom row on our truth table and we see if both switches are true, then the light comes on. We have another Boolean operator called OR, and that's a different kind of condition that we're checking for. This says if either one of those switches is on, then the light will come on. And some of you might have these kind of switches at your house. So we look at x being false and y being false. Well, if both switches are off, the light will not come on. But if either one of them is true, and we've got two conditions where x is false and y is true, the answer will be true. Also, when x is true and y is false, the answer will be true. And then when both of them are true, the light will come on, and the answer is true. Not operation just simply says if x starts out false and we say not x, the result of that is true. If x is true and we say not x, then that means false. It's just like using double negatives in spoken languages. We can combine these operators. Most languages allow us to do this, but not all. Python does. And just like arithmetic operators, the multiply, divide, subtract, modulus, there's precedence among the Boolean operators. Anything in parentheses is evaluated first, then the not. Notice that not is not a binary operator. It doesn't work on two operands. It only works on one operand. So that would be done next. Then and is done before or. Here's an example of a program that you could type in and have Python run for you. So I've hard-coded 3 scores, and I check to see if score 2 is greater than score 1. Then I print score 2 is larger than score 1. Else, print score 1 is larger than score 2. Now, if we were to do a debug on this, you should see that there's a problem. What happens if score 1 is equal to score 2? Then what? So my logic is faulty here. How would you fix that? Let's go to the next if. If score 2 is greater than score 1 and score 2 is less than score 3, then I can print the relationship between those 3 scores. And if that's not the case, then I would just print sorry. The final if says if score 2 is greater than score 1 or score 2 is greater than score 3, then what we know is that score 2 is not the lowest of those 3 numbers. An example of something you can try from the command line. Let's make a list of nums and call them 1, 2, and 3. Then basically we're asking a question. We're saying 1 is not in nums, true? And the answer is it's false. So we'll get printed out false because 1 is in that list of nums. But when we check to see if 4 is not in nums, the answer is true. Things to try. Write yourself a program in Python that prompts for any 3 integers in any order, then prints them out in ascending order. That means from smallest to largest. And I'm asking you to test all possible cases. That means your input, I want you to try putting it already in ascending order. I want you to try putting it in reverse order or in descending order, and make sure that all cases work. Then I want you to think about how you'd change the program if you had 100 numbers that you wanted to put in order. What would you have to do to modify that program? So I encourage you at this point to always keep a working program. So use one of these programs that you're going to start with and then add to it, make changes, try and, or, not logic, and the different relational operators. Thank you.